is changing temperature and pressure to whatever we want. Here is our perfect distillation column. And if I want to put more detail, I would have to put two component splitters. The first gives in the bottoms dichloroethane. The second one would give in the bottoms vinyl chloride. And I would send everything else as this. Okay? So the next step is to actually, since we only have 63% conversion in this reactor, to take the unreacted dichloroethane and recycle it back. So if you, for some reason, you don't have that, go quickly to the class website and download the file with _1. Okay? Does everybody have it? If you go to the class website, go to files. Go to files. And you'll see here vinyl chloride. Oh, I'm in the wrong class. How if we go to the right class? Yeah. Okay, so you should see here vinyl chloride is adjust. And you can really see the name, but probably the oldest file, the bottom file must be the first file. Okay, I shouldn't use long names. But if you hover over it,
it still doesn't do it.
It still doesn't. So that was 6, not that one. Okay. Okay, if you click on it, you see the name. Maybe this one? Right. Okay, maybe the reverse order. Maybe the first one.
If you organize it by just down organize by name. If you
you're right.
you organize yeah.
Okay, let's. If you organize by name, it will be the first one. If you go down, it's going to be the last one. If you go up, it's going to be the first one. So this one, okay? Organize by name, and it should be one. That should be one. All right. So, I'm going to do the recycle at different steps. Right now, we have figured out the flows to make the 100,000 pounds per hour that we need of vinyl chloride without any recycle. So we're wasting more than a third of our dichloroethane in this stream. When we recycle this stream back to the cracking reactor, we're going, if we didn't reduce the feed, we'll be making a lot more than the target, 100 million pounds an hour, 100,000 pounds an hour. So we need to reduce correspondingly the feed flow, and we put an adjust that adjusts the flow of ethylene on the basis of how much vinyl chloride we're making. So to put the recycle, the first thing we're going to do is add the recycle stream without changing our converged state. So to do that, first thing we do is we put red light. So I'm going to put a red light. Then I'm going to disconnect the feed to reactor 2 from reactor 2. I'm going to introduce a zero flow recycle stream and mix it with the existing feed. So since I'm adding zero flow, I'm making no change. What comes out of the mixer then will feed the reactor. So put red light, then go to the reactor, and delete into reactor 2. Okay? Now, go and create a new material stream. Bring it somewhere to the left of the reactor. And the most important thing about this is, well, also temperature and pressure is important, because if we put a mixer, even if we have zero flow, the result, the pressure coming out will be the pressure of the lower of the two streams. Okay? So you do want to put the pressure and the temperature of the feed stream there. So stream name, this is going to be our recycle. Question? So we are feeding at 500 degrees C. So put 500 C, since we have engineering units, you can translate it to engineering units. Pressure 26 atmospheres. And very important, put one of the flows, either mass or molar, 0. Okay? So put 0, I'll put the 0 in the mass flow. And of course, you need to specify composition. It's not important what composition you specify, but in this case, we do know the composition. What will be the composition? Dichloroethane. So you want to choose one for dichloroethane. And click OK. Okay, so put one dichloroethane composition, and other conditions, put the temperature and the pressure, and put 0 mass flow. Why is it still light blue? Because of the red light, exactly. I'll put green light when I have reconnected things to the reactor. So now I'll put the mixer. So I may have to move things a bit to the right to fit it. So take a mixer and put it somewhere here. And choose first feed to reactor 2. And
Wait.
recycle. It's also saved on the website.
Where's the mixer?
An outlet, I think I named it total feed.
Total reactor.
Okay? And of course, not solved. Why?
Well, you're going fast. You're going really fast.
I wrote also detailed instructions, so I'm not going to go particularly slow on this one. I was debating whether to do that also. Last step is connect it to the reactor and only then press the green light. Because I have 0 flow added, I'm exactly where I was before I did all that. So the green light should converge immediately. So I'm going to go back to the reactor, and I'm going to specify total feed. And since I don't use it, that's again because we don't have the green light. At this point, green light. And of course, we're back where we were, and we added the 0 flow recycles. Clear, everyone? Juan, are you caught up now? Good. All right. So, next step is now to do the recycle, the real recycle, using the convergence T that I recommend. So we're going to put a tier, which is what the recycle symbol here is. We're going to put that right before recycle. Okay? And let me push push that down. I'm going to put a convergence T between L and this. How this works when you have that recited? The process that Unison, HYSYS, and most other simulation software uses. When you have it here, you give a value on one side of it, it will follow it all the way through, calculate everything, come back on the other side, and come here. And then this becomes the new guess. It's in essence, guess and check of success substitutions. And that's why on the recycle, if you recall, we used it earlier, we could make the convergence tighter. All right? You have an option where you could recycle the convergence tighter. So, let me put the T. Let me flip it face the other direction. So right-click transform, mirror about the y-axis. And for that T, you can name it convergence T if you want. It's not a real T, you understand that? This is something that we do to help our simulation. At the end of your project, if you have some convergence T's, I'm not requesting that you remove them, but if you want to, save first, okay? Press red light, remove the T, convergence T, and reconnect without the convergence T, and press green light. You should be fine. Okay, so the inlet is B, bottoms, and we have two outlets, and I don't know in which order they will show up, but one outlet will be eventually 0, and the other one will be the one that becomes recycle. So let me name the first one to recycle, and I'll call the second one eventually 0. And instead of specifying splits, I'll go to the worksheet here and I'll specify the eventually 0 to have almost the entire flow coming out of B. And you can see my flow coming out of B. Let's quickly look at it. Because I don't have B here. If we can quickly look at B. You can see that the total mass flow of B is 94315.9. So I want to put 94315 point very close to 9. So go to the T. And go to worksheet, and the eventually 0 is the one that will take 94315, and I'm not going to put 0.9. Let me put 0.9 for a second. Okay. Notice that when I put that, what is the to recycle flow? Minus 1.5. Obviously, we can't have negative flows. So I'll put that a little bit slightly lower than the 0.9. I'll put 0.89. And notice this is 10 to the minus 3, so 0.89 should definitely change that to positive. 315.89, even though it won't show 0.89, show 0.9, you see that this changed now to something tiny positive.
0.9 what?
To something tiny positive. The to recycle, we want to be very small, positive. It doesn't have to be exactly 0. Okay? So you understand what I'm doing? I'm going to be connecting to recycle. Right now the recycle has 0 flow. I will change the flow from 0 to 10 to the minus 3. 8 times 10 to the minus 3. That's a tiny change, given the magnitude flows that we have in the system. So it should immediately converge. That's the philosophy here.
So you do a tiny one, it works every time?
Yeah. Because it's a good, the 0 that is now is a good initial guess for the change to this tiny one. That's the principle. All right. So let's, now this is connected. Now we'll connect the, not eventually 0, but the to recycle bit. Let me, it's pointing this way. Let me flip the to recycle 180. Transform mirror about y-axis. Let's move it closer to the recycle. So this is what I have. And now I'll go to recycle, to the T, to the tier. And inlet is going to be what? To recycle. And outlet is going to be recycle. And you can see immediately. That's the most straightforward, easier way to do that. Everybody clear? So now it's a good time to save. Final. Save, okay? Well, no, I don't want to save in my case because I love the idea otherwise. So now we want to move to change the eventually 0, which is now 94,000, to 0, to exactly 0. In practice, you can always first throw the Hail Mary. The Hail Mary is setting it immediately 0. Save and set it to 0. Worst thing that happens, you crash, you have it saved, go back in. I don't want to take the chance of crashing, so I'm not going to do that. I will do what I did before the port. So I'm going to eventually 0. Right now I have 94,315, and notice I specified that, not the to recycle. Because I don't know how high the to recycle will end up being. But I know exactly how low the eventually 0 is going to be. Okay? So it's now 94,000. If I put 80,000, not 8,000, that would be immediately converged. They green. 60,000. Okay. Sometimes you may see that. Hopefully it will, and it will be fine this time. I say yes and immediately converges. But since it was a bit tricky here, we may want to consider to go slower. I think I went 40,000, but let's go 50,000. Immediately converged. 40,000. Okay. Because I went to 50. Okay, good. Okay, let's go back to 50,000. Okay, 50,000 try converge. So we had trouble there, so let's go 45,000. Immediately converge, 40,000. All right, let's go back. By the way,
I got it to go to 30,000.
yeah, but let me do this. I'll go back to 45,000. I'll go slower. Okay, 45,000 is converged. Let's go 43,000. Worked. 41,000. There's a place where some transition has probably a phase change or something. 41,000 worked. 40,000 works. Let's go 35,000. Works. 30,000. Worked. 20,000. Worked. 15,000. Works. 10,000. Works. 5,000.